Welcome back to day 2 of implicit differentiation. Before we get into some trickier ones, this is a fairly straightforward one, except they are going to start asking you to evaluate them at some point. So this one we're going to evaluate at 2 comma 1. The notation one more time is dy dx, and we're going to evaluate it at 2 comma 1. Well, first let's get the derivative. This is an x term, it becomes 1. This is a y term, it becomes negative 4 dy over dx. This is 10y dy over dx. And then we have a negative 3x squared and a plus 3y squared dy dx. We have 1, 2, 3. We have 3 dy dx terms. Since there's 2 of them on the right, I'll just move the negative 4 one over to the right. It doesn't really matter which side we get them on. So if that's the case, we will have over here, we'll have 10y dy dx. The plus 3y squared dy dx. And when you move that negative 4 over, it becomes a positive 4 dy over dx. Over here, we're going to have the non-dy dx terms. So we already have a 1. I'm going to move this over. It becomes positive 3x squared. Let's take out our common factor of a dy dx, which leaves us with 10y plus this. Whoops. And that equals this, and we divide by what we want to get rid of, and you're going to have a 10y plus 3y squared plus 4 over here, because on this side it cancels out. And there is what dy dx equals. However, we need to evaluate it at a point. Let's do that now. Just so I can write left to right, I'm going to put the dy dx over here, and then we're going to evaluate it at 2 comma 1. So you have 1 plus 3x squared in the numerator. Well, the x value is 2. And in the denominator, we have this. The y value is 1. We have 3 times 1 squared plus 4. And that's going to give us, what is that? That's, remember, exponents first. 4, that's 12. 12 plus 1 is 13. And this is 10 plus 3 plus 4, so that's 17. We have a slope of 13/17. Now this next problem here looks like we have to use a chain rule on the left. So let's get into it. We have ourselves a base and an exponent, so I'm going to put my 5 in front. We're going to leave the base and reduce the exponent by 1. Our base is x cubed plus 2y squared. We did not take a derivative of a y term yet, but right now when we take the derivative of the base, we are. Okay, so now the first term becomes 3x squared, and now we have 4y dy dx. That's the first time we took the derivative of a y term. On the other side here, we have equals y. Well, that means it equals 1 dy dx. Now, we have to get our dy dx terms separate, so I have to distribute this. Let me do that. I'm going to go here and here. So that's going to give us, well, 5 and 3 is 15x squared times this. And then the second multiplication is going to be a 20y times that. Okay, and we have a dy dx with that one. And then over here we have 1 dy dx. All right, well, we have 1 dy dx since they're, all right, well, let's see. It doesn't matter which side we go to, so I have 1 here. I just might as well move that one over because the constant's already by itself. So I have 15x squared here times this. And we're going to have 1 minus, I'm going to do 2 steps in 1. I think you've seen this already. So we're going to have 1 minus 20y. I'll explain in a minute what I'm doing. I'm just taking out my common factor in the same step. And what do we got here? I got this with a dy dx. And you guessed it, to get dy dx by itself, we're going to divide both sides by the exact same thing. 2y squared to the 4th. And over here we have the same thing. And this cancels with this, and we are left with dy dx equals this. That last one was pretty tricky, and that focused on some rational functions. Now we're going to switch gears and look at some trig functions here. Well, let's start off. So we have to take the derivative of this. So we are going to take the derivative of sine, which is cosine. We leave the inside. Now we multiply by the derivative of the inside. Well, the derivative of the inside, this thing right here, this is my f and this is my g, so that would be 3x squared, leave the y cubed, plus leave the x cubed and take the derivative, multiply by 3y squared. And that is a y term. You need a dy over dx. Over here we have a 3. Let's distribute, same thing as the first problem. So that would give us a 3x squared y cubed times cosine of this. Right, that's the first one. And now we're going to distribute over here, and that's going to give me plus 3x cubed y squared. And that one has a dy dx. And over here we have a 3. Our goal is to get dy dx by itself. Well, this one only has one dy dx, so why don't we do this? I have 3x cubed y squared. This is the dy dx term. I'm copying this one over. And that's going to stay over here. And then we're going to move this thing over to the other side because it doesn't have a dy dx. So we have 3 minus. And I think you know what to do. We don't have to take anything out. There's only one term here. So we're going to divide by the same thing we want to get rid of here. And what you do to one side, do to both. Those are 3's. And yes, this cancels with this. And you have dy dx all by itself, and it equals this. Let's look at this one. So that left side, well, if we rewrite the left side, that puts a 1/2 there. We have x cubed, right? We leave our base here. So I didn't take the derivative. I just rewrote it to make it easier. That's a 3. And now we have 2y. So let's jump into the derivative. So now we have a base with an exponent. Let's do the power rule. We put the 1/2 in front. That's a 3, y cubed. Reduce the exponent by 1. We did not take the derivative of a y yet, but now we're going to, because now when we take the derivative of the base, here's where we take the derivative of a y term. So the first one becomes 3x squared, and then the second one is 3y squared dy dx. On the other side there, we have 2 dy dx. Now we have to get our dy dx terms together. We have to combine them. So we want to get this one over here and this one over here together, but what is up with all this mess? Well, here's what I like to do. I'm going to distribute this so we have all unique terms, and then I can easily identify which ones are dy dx and which ones are not. With that said, here we go. Now, before I do that, in Delta Math, they will keep it as a negative exponent on this one, even though it doesn't say any form, but they're confusing. It's confusing with that. So I'm just going to show you how to simplify this one. And quite honestly, before I distribute, I'm going to rewrite this one before I distribute because I think it's a lot easier for everyone to follow me. I'm not going to explain this piece right here. We've done that many, many times. I'm hoping you get the hang of that. Now we're going to multiply it by this. And that's on the right-hand side. All right, so let's distribute. We go here, we do this, and then we distribute here. So that's going to give me a 3x squared in the numerator and this in the denominator. And then when we distribute to the second one there, that's going to give me a 3y squared over this. Doesn't really matter where you put the dy dx. I usually just like to keep it on the outside because I know that's my goal, is to get that by itself. And what do we have over here? Just 2 dy dx. You see how, even though I just made some funky looking fractions, well, I have my dy dx term it's pretty obvious. Okay, so what I'm going to do is, well, I can move them to the left or the right. In this case, I'm just going to move the dy dx over here. This way they're on the same side, and the one without it is by itself over here. And as you can imagine, after we solve for dy dx, this is going to leave us with, oh, I'm sorry, that's an equal sign. That's going to leave us with a complex fraction. I'm going to take this opportunity to show you how we get rid of that, or how we simplify it, because you can never leave a complex fraction. That is Not simplified enough. That's a 2. That's a cube. Oh, there's so many exponents. Holy cow. Did I do it right? We need a dy dx. All right, I think I did it right. Let's continue. So I'm going to move this up. Okay. All right, well, now we take the dy dx out. Now we have 2 minus this. And let's finish this up by dividing by what we want to get rid of. I'm going to divide by this right here. 2 minus 3y squared over this. Okay. Okay, now this one right here. So after you do this, after you divide this and get rid of that divided by that, and now you have dy dx by itself, and it equals this complex fraction right over here. So how do we get rid of that? Well, let's look at the 3 terms, right? There's a denominator of this, a denominator of this, and a denominator of this. The common denominator for all of those 3 terms is going to be a 2 over 2 times radical x cubed plus y cubed. So the way you can get rid of a complex fraction in one simple step is multiply through by the common denominator. And watch what happens. So in the numerator, well, this cancels with this, and the 2 cancels with the 2, and all you're left with is 3x squared. Over here, well, you can't cancel anything out, so just multiply the 2's. Oops, let me make some room here. And then what do we have here? Here's my minus sign. So over here, that entire thing cancels with that, and you're left with 3y squared. And that is your dy dx. Oh boy, look at this one. All right, so we're going to do some implicit differentiation, but after we find the derivative, we also have to evaluate the slope of the tangent line, and then we must come up with the equation of the tangent line. Okay? Don't forget, the equation of all tangent lines can be found using the point-slope form of the equation. There's 2 things we need. We need a point, and we need a slope. All right, well, why don't we find the y values first, because we are going to need some xy points. Well, the only thing we now know is x equals 1. All right, well, here's our equation. 1 minus x cubed minus 4xy squared equals this. Well, all I can do right now is plug in a 1, because I know x is 1, so that would give me this. That would be 1 times 1 times 1. This would be 4 times 1 times y squared, and then I have this. All right, well, 1 minus 1, what is that going to give us? We have negative 4y squared equals negative this. All right, well, let's see what we get. I'm going to get those onto the same side, which would make it y to the 4th minus 4y squared. I'm going to take out a common factor of a y squared, which leaves me with y squared minus 4. This is y squared times y plus 2 times y minus 2. Which means we have, when we set each of these equal to 0, you're going to get y equals 0, you're going to get y equals negative 2, and you're going to get y equals positive 2. So that means we have to find all the equations of the tangent lines to the curve when x is 1. Well, there's 3 lines. There's 3 points when x is 1. We have when x is 1, y is 0, when x is 1, y is negative 2, and when x is 1, y is positive 2. Okay, well, we have 3 points. Now I guess we need 3 slopes. So let's jump into the derivative and see what happens here. All right, so here's my equation. 1 minus x cubed minus 4xy squared equals negative y to the 4th. Let's take the derivative. Constants become 0. This one is negative 3x squared. Now remember here, we have to use ourselves the product rule, okay? If you're not sure what to do with the minus, you can do something like this. Why don't you just do plus and keep the minus with the 4x? So I'm going to add to this. Well, the derivative of the first one is negative 4. I'm going to leave the y squared. Plus, now I'm going to leave the negative 4x. And I'm going to take the derivative of y squared, which is 2y dy dx. On the other side, we get negative 4y to the 3rd. Don't forget dy dx. All right, let's clean this up a little bit. So there's not much to distribute, so I just have negative 3x squared minus 4y squared minus, I'm sorry, that's an 8. 4 times 2 I got to do, that is a 8xy dy dx. And what do we have here? Negative 4y cubed dy dx. All right, well now let's find out which ones are dy dx's. We have these two, and these two are not. All right, well let's get these over on the correct side here. I'm going to have a negative 8xy dy dx, and I'm going to move it over so it's positive 4y cubed dy dx. And now we must move the other ones over, so I'm going to get a positive 4y squared and a positive 3x squared. Doesn't matter which one's first or second, you're just adding them. All right, well, hopefully now we're at a point where you can recognize what we're about to do. We're going to take out our common factor, negative 8xy plus 4y cubed. And I think you can just follow along here. The rest of it is the same type of pattern. Those cancel, and here's our derivative. Okay, that's what dy dx equals. Well, remember, we have to come up with all the equations of the tangent lines. We have 3 equations at x equals 1. All right? So for the first one, let me just do it like this. We have the first one. When we had, what was that point? 0, 1. So the first one was at, not 0, 1, 1, 0. Okay, so at the coordinate 1, 0, let's find the slope of the tangent line when x is 1 and y is 0. So that's going to be a 0 squared times 1 squared. And the denominator is a negative. X is 1, y is 0, y is 0. All right, so that one is going to, well, that's 0. That's going to be a 3 in the numerator. That's 0. That's 0. That's undefined. We have an undefined slope. Okay, so I'm going to just write up here. So we know for this one, we found that the slope of the tangent line was undefined. I was going to write 3 over 0, but it's undefined. All right, we'll write the equation in a moment. So now on to the second one. The second one was 1 comma negative 2, and then the third point was 1 comma positive 2. Let's find out what the slopes of these are, and then we'll write the equations. All right, this is the slope for our first one, the work for the first one, and here is, let's change the color. So here is the slope for the second one. Now, we want to evaluate dy dx at the other point, 1 comma negative 2. All right, let's do the same thing. We're going to get 4. Now I have a negative 2 squared. This is 3 times x squared. The denominator is negative 8 times x times y plus 4 times y cubed. Let's see what this equals. All right, so that's going to be, remember exponents first, that's 4. 4 times 4, we have 16 plus 3 in the numerator. And the denominator, that's a negative negative, which is positive 16. And remember, you do exponents first, so negative, 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 that's negative 8. Negative 8 times 4 is negative 32, which gives us 19 over negative 16. And let's just leave it. That's fine. That's your slope. Okay, the third one, I'll do it in red. The third slope, we want to evaluate dy dx at the point 1 comma positive 2. All right. So we have 4 times the y value squared plus 3 times the x value squared, and then that's all over negative 8 times the x value times the y value plus 4 times the y value cubed. And this is going to equal, that's 4. 4 times 4 is 16 plus 3. Down here, now that's a negative 16, and that's 2 times 2 times 2 is 8. 8 times 4 is a positive 32, which means we get 19 over a positive 16. Okay, so here, let's go back. So now this one right here, number 3, this is the one we just did. This is y minus y1 equals m times x minus x1. Well, we now know that it's going to be y minus the y value. We know that the slope is 19 over 16, and the x value is 1, so it's x minus 1. There's one equation. The next equation, up here, we'll do this one in yellow. We have y minus a minus 2 equals, well, the slope was over here in blue. The slope was negative 19 over 16, and it was x minus a 1. There's my second equation. I wanted to save this one for last because it's a little unique. Undefined slope. Well, remember what an undefined slope is. It's vertical, okay? You can't plug in, if I were to plug in an undefined value in the m, I can't multiply by an undefined value. These are the special cases. Vertical lines are always x equals, okay? So you just need to figure out what x value it's going through. If it's going through the x value 1, then it's the equation x equals 1. There are your 3 equations. Similar to the last question, we're going to find all the equations of the tangent lines of the curve when y equals 1. Now they're giving us y instead of x. Well, that's fine. We still have our equation here, y to the 4th. This is our curve. And instead of knowing x, we know y, so that's fine. Just plug in a y. So we y equals 1. So y is that, and we know this is a 1, and we need to minus, that's going to give us 1. Sorry, my 3's are getting sloppy there. So what do we get there? Move it over, I get 3x equals 6. Okay, so we get x equals 2. There's only 1 point. Okay, so that looks like when y is 1, x is 2. So we have a 2, 1 point. All right, fine. With that said, to find the equation of a tangent line, we need to do y minus y1 equals m times x minus x1. So far we have this. We now know the point on the line. When y is 1, we have 2, so that's going to be y minus our y value. We have x minus our x value. We need to find the slope of the tangent line. The slope of the tangent line, let's do it in orange. So that's going to become 4y cubed. I'm over here starting, okay? And that's going to be a dy dx. The next term, we have equals. Now, this is a product rule. Just put the 3 with the x and think of it as 3x times y. So it's going to be 3, leave the y. We took the derivative of an x, not a y. Plus, now we leave the 3x, and now is when we take the derivative of y. The y becomes 1 dy dx. Don't get confused. I have a dy dx here. There's no y. Yeah, well, because it was 1y, it became 1. All right. This dy dx goes with 3x. Let's continue. The last term is a negative 5. That becomes 0. Fine. Let's move on. We have to get our dy dx terms on the same side. I will move them over here. I have 4y cubed. I'm going to do the same thing and take out the dy dx at the same time. So when I move that one over, I get negative 3x. And they both have a dy dx, so I'm just going to take it out. And then we have 3y on that side. Okay, if I did lose you, just distribute here. Okay, it's the same thing. I just took the dy dx out. And now we have our answer. Well, not our answer, but at least our derivative so we can find the answer. And that cancels with that. And now, if we want to, let's change the color. I want to evaluate dy dx. We want to do it when the point is 2, 1. The y value is 1. The y value is 1. And the x value is 2. And that's going to give us 3 over 4 minus 6. That is negative 3/2. That's the slope of the tangent line. There's the equation of the tangent line to the curve when y is 1.